So a couple sections ago we talked about alpha and beta decay processes. In this section we're going to talk about gamma decay processes. So simply radioisotopes that emit gamma rays for them to become more stable. So remember, gamma rays are just high energy being emitted. They're high energy photons. We just saw the electromagnetic spectrum. The gamma rays are way on the high energy end. So during some radioactive processes, gamma rays are emitted that allow for us to get a more stable daughter than we did than the parent was. Technetium 99M, we can see it here. Our technetium 99M is a radioactive isotope. That M stands for metastable, which means it's not a stable isotope, but by simply releasing gamma rays, it will become a more stable isotope. Not fully stable, but more stable. Okay, so in this process, gamma rays are emitted. So we show the gamma rays as a product along with the daughter nuclide. But notice that gamma rays, because they're simply energy and not matter, they don't contain protons or neutrons. The atomic number and the mass number are both 0. So a lot of times it'll just be written as a gamma without those numbers. But for this class, we're showing you those numbers to allow you to understand that that's pure energy that's coming out of the atom, the nuclide or the nucleus, to help make it more stable. Okay, so our reaction would show that our technetium 99M is undergoing radioactive decay by emitting gamma rays, and those gamma rays produce a daughter, or the release of those gamma rays produce a daughter that is just technetium 99. It's not metastable anymore. Its released energy has made itself more stable. Okay, it's still radioactive. That daughter is still radioactive, but it's more stable than 99M was. Okay, we use technetium 99M for imaging. We put that in your body. It emits gamma rays that are detectable, and we can use those to image inside your body without having to cut into you and see what's going on. Gamma rays are also used to kill bacteria. A lot of time, produce is irradiated using gamma rays because it does a very efficient job of getting rid of bacteria. Anytime we want to get rid of bacteria, for example, the other example here is there are machines that produce gamma rays that irradiate surgical instrumentation before it's used, so that it is sterile and isn't spreading bacteria. An example here is we have gamma ray emission. Barium 137M is a metastable version of barium 137. It comes from some radioactive decays. So barium 137 is a metastable species, so that means after some time it's going to release energy and produce a more stable barium 137. So if we're going to write the equation that depicts this, we're going to do 137M, showing that it's got some extra energy it needs to release. Barium's atomic number is 56, so it's going to be 137M 56 barium. It's going to produce the daughter, which is 137 without the M, 56 barium. So it's not losing or gaining protons or neutrons, it's simply releasing energy. So it's the barium plus, and I'll do the 00 gamma, so we can see that's pure energy leaving. Okay, so the process that the radioactive process that takes barium-137M to barium-137, a more stable version of barium-137, is the simple release of a gamma ray. Right? That's this.